So now we will take another look at a way to solve systems of equations, and this will be using the elimination method. In the elimination method, our goal is to solve the systems of equations by eliminating one variable to solve for the other. So let's take a look at an example, and that will really show you how it works. So let's say you're asked to solve the following system of equations, x plus y equals -2 and x minus y equals -6, and you're asked to solve this using elimination. So my very first step that I will always do is label my two equations. So I'm going to call this one equation 1 and this one equation 2. Now my goal is to get rid of one of my variables. I'm going to eliminate it. That is my goal. And I'm going to do that by adding my two equations. And when I add these two equations, what I notice is, hey, I have x plus x. That gives me 2x. A positive y plus a negative y, the y's cancel out. I eliminated them. And -2 plus a -6 gives me a -8. Well, now I just have one variable. And we learned back in chapters 1 and 2 how to solve for one variable. So my goal now will just be to solve for one variable. Divide both sides by 2. I get x equals -4. Well, hey, I'm not done. All I did was solve for x. I need to find my y. I can go back and pick either one of these equations. So I choose to use the first one, and where x plus y equals a -2, I'm going to substitute in a -4 for my x. And when I do that, I solve and I get for my y. So for my y, I got a 2. This means the answer to my system of equations, or the solution, is x is a -4 and y is a 2. Now I can check my answer, and the way I can check my answer is I go back in and I put -4 here for x and 2 for y, and it should make this equation work, and it does. And if I put a -4 in here and a 2 for y there, I get a -6. So this solution needs to work for both of those equations. So let's take a look at another solving the system by elimination. So if I asked you to solve 3x minus y equals 7 and 10x minus 5y equals 25, my first step is label both of my equations. It helps me to keep organized. Now I'm going to take a look at these and I say, hey, last time all I had to do was add the two equations and one of them eliminated immediately and disappeared. Well, that is not the case this time. So what am I going to do? So what I can do is decide to multiply one of these equations by some factor to make it have the same variable, the opposite variable. So here I am deciding to eliminate my y's. So when I decide to eliminate my y's, what I'm going to need up here is a positive 5y, because if I have a positive 5y here and I add it to a negative 5y, then my y's will cancel out. I could also have chosen to eliminate my x's, but if I did that, I would have to multiply both equations by something so that they could cancel out. So it's just easier if I look at this and say, hey, I'm going to eliminate my y's. So I've decided to eliminate my y's. I'm going to multiply equation 1 by 5. So the way that I show that is I say, hey, -5 times equation 1. This is why it's so important to keep your equations labeled. It really helps you keep things in order. So if I multiply equation 1 by -5, I need to multiply everything by -5. And the reason that I can do that is the multiplication property of equality allows me to do that. Keeps the equation balanced. So I say -5 times 3x gives me a -15x, and a -5 times a -y gives me a positive 5y, and a -y times 7 gives me a -35. Now I'm going to add my new equation 1 and my old equation 2 together, and when I do that, I get -5x. Hey, my y's cancel out. Well, that was my goal. I wanted them to cancel out. I was trying to eliminate them. And -35 plus 25 gives me a -10. I now solve for this, and I get x equal 2. Now, I am not done. All I have found is x. You've only done half the work. I need to go back and find my y. And I can choose whichever equation I want to for that. I could choose my equation 1, my equation 2, or my new equation 1. But I decided to go back in and use my equation 1. So I go back into my equation 1, and I substitute 2 in for x, and I get 3 times 2 minus y equals 7. Solve it, 6 minus y equals 7, so y equals negative 1. This means my solution is 2 comma negative 1. Now, I can go back in and check my answers. Where there is an x, I put in a 2. Where there is a y, I put in a negative 1. It worked into equation 1. I stuck it into equation 2, and it worked in equation 2. That means it was the right answer. Now let's take another look at solving the system using elimination of these two equations. So here's equation 1, here's equation 2. I go ahead and say, hey, I'm going to eliminate my x's because I notice that my x's are opposite. And I do that, and I get 0x plus 0y. Hey, and the other side equals 0. 0 equals 0. Well, what does that mean? I didn't solve for an x. I didn't solve for a y. I got 0 equals 0. That doesn't mean x equals 0, and that doesn't mean y equals 0. What that means is 0 equals 0. Well, what would that look like? Let's think back to our graphing. And the last problem that we had just done, we found a solution. And if I were to graph those equations, what I would have noticed was that they intersected at one point, and exactly one point. When I solve an equation like this and I get a true statement, when I have a true statement, this means that the lines coincide, or they are the same line. So every solution that works for equation 1 will work for equation 2. So that means infinitely many solutions, and that's what I would put. Infinite solutions. Okay? And what I notice is if I went back here, hey, these two equations are really the same thing. This one's just multiplied by a negative 1, and otherwise they are the same. So you could have that type of situation if I graphed them. Again, those would be the same line sitting right on top of each other. So let's take a look at another example. Here I say solve by the elimination method. 8x minus 2y equals 2, 4x minus y equals 2. I'm going to label one equation 1, the other one equation 2. I'm going to say, hey, I'm going to get rid of my x's. So I'm going to multiply equation 2 by a negative 2, because if I multiply that by a negative 2, I would get a negative 8 right here, and then my x's would cancel out. So I go ahead and here's my equation 1. I multiply negative 2 times equation 2, and I get negative x plus negative 2 times negative y gives me positive 2y. Negative 2 times 2 gives me a negative 4. I add them together, and I got 0x plus 0y equals negative 2. Well, this time I got 0 equals negative 2. Well, that is not a true statement. So what I notice is I'm going to think again back to my graphing. And what this means is that when I come up with a not true statement, that means my lines are parallel. And they never intersect, so they don't have any solutions. So we would say no solutions. So one thing to notice, it doesn't matter whether I use the graphing technique to solve my system or if I use elimination. I'm always going to have one of three choices, either exactly one solution, infinitely many solutions, or no solutions at all.